Hello, welcome for today our science lesson. We are going to look into the Earth in space, and specifically we'll be looking at the gravity, orbit and tides. Before we look on the gravity, the orbits and the tides, we'll have to review first of all about the Earth. As a planet, in the previous lesson, we learned that the Earth is one of the major planets that we have in the universe. Therefore, we'll be able to make some few observations about the shape of the Earth. As we look into this observation, we learned that the Earth is in a ellipsoid shape, whereby as it being ellipsoid shape, it does not have an exact. It is neither flat nor is it round. It is very true. And such a shape in science we call it geoid. So geoid, or you can also call it oblate spheroid. Now, having looked at this shape of the Earth, it is this shape of the Earth which is in sphere. It is actually oblate, or it's actually in a spheroidal model, or you can also call it ellipsoid. Having that in our mind, we'll be able to look at the reasons that make this Earth look shape. We'll be able to look at it. Then, as we look into it, let us preview what causes this shape of the Earth. Indeed, the Earth has got two features that we have to know. This shape of the Earth has been caused by the flattening of the poles. What causes the flattened poles of the Earth? What causes these? There are various forces that are interested or that work on the shape of the Earth and make it flattened. For example, the two forces that work at the poles of the Earth to make it flattened, especially at the poles, we call it centripetal force. And then another force, sometime, that makes the Earth bulge outwards, especially at the equatorial region. It's make it bulge, the force that makes the Earth to bulge. We call it centrifugal. These are two major forces that plays the role of the shape of the Earth. And then another force that also will be able to look at it is the gravity. Gravity is the force of attraction. This force tends to pull all objects towards the center of the Earth. And therefore, when we look onto this, we'll be able to understand about what makes. These are the three forces that are responsible for the shape of the Earth. And therefore, exactly the shape of the Earth, we'll just have to demonstrate it shortly here. you'll find that this is the North Pole, and then this is the South Pole, and then this is the equatorial distance. We have the equator, and the equator is always at 0 degrees. Therefore, we are looking at these poles. This flattening of the poles of the Earth is the one that we are looking at it. Therefore, this is what makes the shape of the Earth to look ellipsoid, or it looks spheroidal. Now, the equatorial distance is about 80 kilometers. It's 400,080 kilometers. While we also have the polar distance. The polar distance of the Earth, it has 39,999 kilometers. When you look at the equatorial distance, is slightly more than the polar distance, because as the Earth is trying to rotate on its own axis, it bulges away. Therefore, the centrifugal force is the one that makes the Earth bulges outwards, and then as the centripetal force works on the poles, making it to be flattened, therefore creating an ellipsoid shape of the Earth. Then, in this process, we'll be able to see another force of gravity away from centripetal and centrifugal forces that works on the shape of the Earth. Another force is the gravity. As we have also seen that gravity is a force of attraction. Gravity is a force of attraction. The more the mass of an object has, you'll find that the stronger the force, the pulling force that is between the two forces. Now, as a result of that, this force makes the Earth or all objects to be attracted at the center. For example, when you try to throw a ball into the space, you'll find it coming back at the center of the Earth. Suppose there was no gravity on Earth, all objects will be floating above. Therefore, this force is the one that makes us to stay on the ground of the Earth. We are able to move. We are able also to remain on Earth. We have this force of gravity. It operates in what we call the field of gravity. It operates in a field of gravity. And if you throw, as I've reminded us, that if you throw a ball into the air, automatically it will still come back to the center or to the ground of the Earth. That means in the place where there is the Earth, there are fields of gravity. And this force of gravity is the one that works on Earth. It comes from the main object in the solar system that is called Sun. Sun is relatively around 150 million kilometers away from planet Earth. That is the distance that we know. But now this distance between the Earth and the Sun, the Earth and the Sun, This distance is the one that gives us planet Earth is found in the space where there is a field of gravity. This is now where there's a gravitational field. And all objects that are found within this area or within this region are affected by this force of gravity. Remember, it's the same force of gravity that holds Earth on its space. And as it's being held on its space, it is here be able to find its orbit, as we'll be able to look in the next lesson as we move on. Therefore, I want us to understand majorly on how the gravity works. We have seen the distance between the Earth and also the Sun. That distance is the one that subjects the Earth, planet Earth, in the field of gravitational force. Therefore, this force will always also work on the Earth. Suppose this is the Earth. The force will work or will act on this Earth from all directions. These forces will work from all directions. It is not only from one direction. These arrows represent the forces or represent the force of gravity. Therefore, when this force work on the Earth, therefore all objects that are found in the Earth will always have the same effect. And that is why planet Earth, when you go onto it, it is mostly affected by this force of gravity, and this because planet Earth is found in the field of gravitational force where the Sun is found. And the more you move away from this field of gravity, the lesser the effect you can feel. Therefore, the strength of the gravity of the gravitational force reduces as the distance from the Earth increases. When you tend to increase the distance from the Earth, therefore, the force of gravity also will do what? Reduces. The force of gravity reduces as one moves away. As one moves away from the Earth. This is the reason why, when in the previous lesson we were looking at the moon, it is the reason why moon is relatively some distance away from the Earth. And when you go in the gravity of the moon, you'll find that in the moon there is very little gravitational force. It cannot even be felt. Therefore, objects that can be, if you are in the moon, you throw an object into the space of the moon, there will be no effect of the gravity. Therefore, the object may not come back as we have been able to see. If you throw this object, it comes back on Earth. But if it is in the moon, it goes and goes and goes. That means there is very little or negligible gravity in the moon, as we have been able to look at. Now, the planet of our solar system lies within the sun's gravitational fields. That is what we have been able to look at. And as a result, they are pulled towards the sun by the gravitational forces. This is therefore, this force works in two ways. It is the force that holds this force of gravity it is the one that holds. It holds the Earth on its orbit. It holds the Earth on its orbit. That is one effect of the gravity. Then we'll be able to look at the orbit as we move on. The next thing, that this force is the one that acts on the Earth. The force of gravity, it acts on the Earth as a planet, attracting all objects, including human being, all objects at the center. These are the two effects of this force as we have been able to learn. Therefore, it is quite important that we are looking into it. Let's move on as we look into the effect of this force. Then we'll be able to learn. Let us look at an orbit. Then what is an orbit? Let's look at an orbit. An orbit is a path. This is simply a path on which the Earth follows as it revolves around the sun. An orbit is simply a path on Earth as the Earth follows, it revolves around the sun. Therefore, also an orbit is a trajectory movement. It's a trajectory movement of the gravitational force that makes it to be curved, to look curved. Therefore, we are able to learn and understand. We are able to learn and understand that the Earth has to make some movement. Therefore, the Earth makes some movement. And there are two specific movements that the Earth makes. One of the movement is revolution. The Earth makes revolution. And as it revolves around the sun, it follows the path that is known as the orbit. The next movement the Earth also makes, the Earth makes what we call rotation. It rotates. And as the Earth rotates, it rotates on its own axis. Therefore, we are able to look at these movements. We'll be able to look into details and how it affects, because some of these movements are the ones that are affecting the tides and also the orbit. First of all, let us look at the effect of one of the movements that is known as revolution. As the Earth revolves around the sun on its own orbit, there are some effects that are felt on planet Earth. This revolution takes around 365.25 days. These are the number of days over which the Earth make a complete revolution. Therefore, one of the effects that may be felt as the Earth revolves, one, it causes the 4 seasons. The movement causes 4 seasons. That is, we know we have the 4 seasons on Earth. We'll be able to handle the seasons. Allow me to illustrate these 4 seasons, how they occur. That is, as one of the effects. We assume we have the sun here, and then this is now the path that is followed. This is what we call the orbit. The path that is followed by the Earth as it moves around the sun. Therefore, one point, this is just a representation of the Earth. And then it always revolves in this direction. Therefore, we have 1, can have 2, this is 3. Just these numbers represent the 4 seasons. This season, we can have it known as summer. Okay, these represent the Earth. The Earth is following the path, that is orbit, as it goes around the sun. The sun gives constant light in all directions. Therefore, this is a summer season, and then summer season is followed by autumn. And then it's followed by the spring. Then after the spring, we'll have another season. We have summer, autumn, spring, and we have winter. These seasons are always an effect as a result of the revolution of the Earth around the sun. And a whole complete revolution, we have seen it takes around 365.25 days. For example, from seasons of summer, this is now where the Earth is. You will find that the northern hemisphere is experiencing enough light from the sun, and therefore in the southern hemisphere there will be some little light or little solar radiation around the regions. Therefore, these variations are going to be felt in various seasons as we move. Now, from one season to another, we are also able to calculate or to identify the number of days. For example, during the summer season, how long will it take for the Earth to reach autumn? At the same time, how long will it take to reach at the winter season, so that we can begin again another season? These 4 seasons circulate along the Earth in 12 period of months. Therefore, we'll be able to look into it as we move on. Next thing that we are going to look at, the second effect of the revolution of the Earth around the sun is that there are some variation. Variation occurs, especially the variation occurs in time. There are variation of time that occurs as a result of this. Now, as the Earth revolves around the sun, this one being representing various seasons, you will find that this area, this region will receive light, that is solar radiation. As it moves to this point, it changes. The same phase does not receive solar radiation, And as you move on to the next, that is during the spring, this southern part, the southern hemisphere, is the one that experiences solar radiation. And therefore, as you move also away, you will experience that this eastern part is the one that are experiencing the solar radiation. Therefore, this revolution, we are terming it, is causing variation in time. And as you move along throughout the year, there are some variation that occurs in specific regions, in specific seasons as you move on. And lastly, the effect that we'll be able to dwell on is that it causes changes in the midday sun also of the Earth's orbit, that is during elliptical period, and you'll be able to see various changes as we move on. Another effect is that the revolution is the one that is responsible for causing what we call the lunar eclipse. Then that is where we'll be heading. We'll be looking into the eclipse as we look into the tides also. Those are some of the effects of one of the movements that we call them revolution. Let us also explore another effect of the rotation. Another effect of the rotation. When the Earth is rotating on its own axis, the Earth rotates on its own axis. It takes 24 hours to make a complete rotation. A complete rotation of the Earth takes 24 hours to make that complete rotation on its own axis. And it creates, one of the effects is that it creates day and night. It also causes deflection of winds. We have day and night. That is one effect. Another effect, there's some deflection of wind. Deflection of wind on the planetary system. And also it causes what we call the difference between the longitude. The difference between the longitude are experienced. And lastly, when the Earth is making its rotation, it will also cause what you call the rising. It causes the rising and the falling. Rising and falling of tides. As the Earth rotates on its own axis, the last effect that it causes, we've been able to see that it causes the rising and the falling of ocean tides. Rising and falling of tides. We'll be able also to look into that. It is because of this movement of rotation that we'll be able to look into the various tides. And then what is a tide? Because you had been able to look at the effect. It is one of the effects from the rotation of the Earth. As the Earth moves around, it causes the rising and falling of the ocean tides, we'll be able to look at the tide. What is a tide then? A tide is a periodic rise and fall of water level in the ocean, or also it can also happen in the sea. This occurs when the moon and the sun exerts pressure, that is a gravitational pull, not pressure, as the moon and the sun exert gravity on the water bodies around the earth. That is now where we'll be able to find the tide being formed. Then, how are tides occurring? Let us look onto the chart so that we are able to see how a tide, we have been able to look at, this is the occurrence of the tide. The tide occurs when the earth is subjected to the gravitational pull from the moon and also the sun. This is the moon, and this is a representation of our earth, that is earth, planet earth. We are able to see this is representing the gravitational pull that comes from the moon towards the earth. When the moon's gravitational pull exerted towards the earth, what will happen? The water will move to point A and also to point B. When this water moves, they are going to flow in this direction from point C also, and also from point D as they move. As they move around this region, you will find that this is the region that will have a high tide, resulting into the tide being formed here. And then also at point B will also have another tide will be formed. Therefore, as the waves rise up and falls around this area, that's now where we have been able to look at. That is how a tide is formed. At the same time, the earth may also be subjected to the gravity that comes also from the sun. When the sun gravitational pull is also concerned with the moon, it affects the moon, and the moon also affects the earth. Therefore, causing the water from point D to move to point B, and then the water that are found at point C, they move also at point B. In the also opposite direction, they move at point A, and then they move at point A. And as they converge here, this is where a point where we'll be having a high tide, and this point will be having a high tide. What about in the North Poles? The water bodies that are found in the North Poles will also be experiencing some tidal waves, because the water have decided to move along the equatorial region. They make this the equatorial belt to bulge. As it bulges outward, therefore we'll have a high tide being formed in the northern regions, and also another high tide being formed in the southern region. That's now the occurrence of a tide and how it is formed. Sometimes there are different levels. The period at which the moon affect what we call the tidal range, it takes around 28 days. And there is a period that we call it CZG. This is the period when the gravitational pull have been affecting both the moon, both the moon and the earth. But now the sun is situated somewhere here, and all effect of the gravity is affecting both of them. That's now when the sun is around this region, affecting the moon. the moon also affects the earth. This is the period that we refer to it as syzygy. And during this period, the tidal range occurs twice. During a half of these 28 days, that is, one period will occur at 14 days, and another one will take its course in the remaining 14 days to complete a whole movement. Now, we also learned that the moon also goes around the earth. As it goes around the earth, it also follows the path known as orbit. The moon has an orbit through which it uses to revolve around the earth. Therefore, a period of 28 days when there is syzygy, that means the moon has completed one revolution and now it's beginning a new phase. That's now why we can be able to understand about the period of months. Moons tend to appear every new month. There is new phases of the moon. There are new phases of the moon. We'll be able to look into them maybe in the lesson that we'll be looking at the revolution and also the eclipse that are being caused by the sun. Now, it is now during this season we will also be able to understand syzygy occurs and also the eclipses will be able to be occurring and the effect will be felt on Earth's surface. That is how we have been able to look at the occurrence of a tide. Let's move on and look into the next part. Now, as the moon goes around the earth, we have been able to see it generate what we call the tides. And there are different tides that are generated. Different types of tides that are generated. We'll be able to list them and then discuss how they are formed. We'll have what we call the Perigean Tide. We'll have a Perigean Tide. And then we also have another type of tide, it's called Perigean Tide. And then we have the Neap Tide. Those are the various types of tides that do occur along in the course of the tidal range on Earth's surface. How an Perigean Tide occurs, Perigean Tide and the Neap Tide, how they occur, there are some slight variation, just some slight differences. But before we look into it, let us look at how a range of a tide appears first along the large water bodies. We can have a water body in this manner. This one is representing the land. And then this is the water body. It can be the ocean or the sea. And then it occurs in the regions that are neighboring the ocean or also the land. Call them along the coasts. During that period of syzygy, we'll find that there will be water levels increasing in this region, that is in the ocean or the sea, When water level increases, the water will tend to move from this point. Let me just mark it. This is A. And then we'll have this is point B. And then we'll have this is point C. During that period, there will be enormous water level that will come and create a high tide. Now, this difference from the normal, when the tide occurs here, this range, because the tides normally occurs in motion of waves. In motion of waves. We will not go into waves, but I'm looking at this range. At a given time, when water retreats back, now after the next period of 14 days, the water level may come and also come closer. This is where we have the low tide. At point C, we'll have generated what we call a high tide. And then when water moves or retreats at point B, it has generated what we call the low tide. While point A means it's the normal shoreline, where water normally comes and hit back and it goes back to the ocean. Now, during this movement of the water, there is something that will be generated in form of the water forces moving again. As it reaches here, it goes back. This movement is going to generate what we call an ocean gyre. Because the water that are closer where the sun's radiation is, for example, that is during the day, then the water is heated up, and then deep into the ocean or into the sea, we have cold currents around here, and then along the shore, there will be some warm currents coming from the land because of the excessive heat that has been absorbed in the crustal rocks, making the region experience what we call the warm current. Therefore, this warm current comes and meets with the cold current in a place, and as it changes, it moves on the ocean now, or maybe on the sea, it becomes a warm current. When it is deep into the ocean, it becomes a very cold current. Therefore, in a place where it meets and exchange the movement of the water, we call them the water. This water movement, as they exchange into the temperature, it is in a place what we call an ocean gyre that will have an ocean current being generated into another. The cold current come and loses its temperature and attain the new temperature by the warm current that is coming from the land. As it moves, it generates what we call a warm current. Therefore, during this period also, we experience a high tide. We experience a high tide. And as the high tide occurs, that is now where we will say that the earth and the moon are in the same point that we call the CZG. And as a result of that, it has generated the high tide. When the water retreats in the next level, the water level drops, it goes to what we call the low tide, and then to the normal. Periodically, these tides occurs periodic because the movement of the moon always has never stopped. It is in constant motion. Therefore, after a period when the moon, the sun, and the earth are in a straight line, That is the time we experience high tides along the coastal region. That's now where the ocean water occurs. Let's look shortly at how the following tides are formed, then we'll be winding up. There are various tides that we have discovered are formed during the formation of these tides. And one, we have been able to look at it, is what we call the Perigean Tide. I'll be able to demonstrate it using a diagram so that we'll be able to understand much better. I will repeat the diagram that we had drawn representing various phases of the earth so that we are able to see this one is still represent the earth. Now, there is a point that we are supposed to understand from this diagram. I will use point 3. This is now the earth. Is just following an orbit, and there is a moon somewhere. The moon also may have its own orbit. Therefore, we may have moon. This is the moon. These represent the moon, and these represent the earth. We are looking at the Perigean Tide. During the movement of the moon, Perigean Tide is formed exactly at this point. When the moon comes and is seen in the right angle, where there is a right angle, when you take an angular between the earth and its orbit from the original point, this angle is around 90 degrees. Therefore, Perigean Tide is formed during the period when the moon angular revolution around the earth is appearing and making an angular of 90 degrees. That's now where a Perigean Tide is formed. And this time, this type of tide is not having a lot of effect because it is a low tide. And then because it is very low, it's a low tide, it is also accompanied with some various types of small waves and tidal ranges. There are various tidal ranges. Various tidal ranges are also found along the area. That is now a simple demonstration showing how a Perigean Tide occurs. Sometime Perigean Tide occurs Perigean Tide occurs around this area When you take the angular direction, it occurs in the angular direction of 60 degrees. And this is the point on Earth where water has been moving from point, I had illustrated from point C, they are moving to point A. This is now where it is characterized by the high tide and various tidal ranges are affected on Earth's surface. We'll have what we call various tidal ranges. There are subtypes of tides that are formed within the 60 angular formation. That is now how a Perigean tide is formed. And we also look at the neap tide. We also look at the neap tide. When the neap tide occurs, it occurs almost a period when now the Earth, this is the Earth and the Moon are in a straight line. That is where the neap tide occurs. This has represented the Moon, and the Moon has occurred in a line, in an angular straight line around 180 degrees, whereby we are able to see the Moon's at its highest effect affecting the Earth. Therefore, the tidal range that are also going to be felt, the tidal ranges that are going to be felt around the Earth's surface are very rigorous. This is the time when these tides are very high and are witnessed on the Earth's surface in various oceans and also the seas, because the water has moved from their various positions and around the equatorial regions, causing the high tide that is felt on Earth's surface. And as a result of that, there will be some effect of those tides, as we'll be able to look at them in the next lesson. Therefore, this is how the formation of the various types of tides and how they occur in various regions, but on planet Earth, because we have been able to understand it results from various movements of the Earth that we are able to learn. And lastly, let's look at some few tasks or some few questions that will help us to remember. We have been able to look at the tides. We have been able to look at the tides. Then, what is a tide? The second question, we have been looking at about the orbits. And then you name the movement. Let us name the movement. The movement the Earth makes. That is around the sun. And then the last question, that will be number 4, we'll have to identify 3 tides. We'll have to identify the 3 tides along the way. Now, in the face of the earth, initially we've been able to look at the shape of the earth, and we learned that the earth is made up of looks like a spherical shape. It is not flat, neither is it round. That kind of shape we refer to it as oblate, spheroid, or can also call it ellipsoid. As it occurs, there are some special movement that the earth makes, and one of that movement that we are going to answer is the rotation and the revolution. As we have been able to look at one of the effects of the rotation of the earth, it is the one effect that is causing the tides to be formed on Earth's surface. Therefore, what is a tide? A tide, we have learned that it is a periodic rise and fall of the water level in the water bodies. It can be in the ocean or also in the sea. That is simply what the tide means. And then what is an orbit? An orbit, we have learned that as the earth moves around the sun, it makes the revolution. The revolution now becomes the movement over which the earth goes around the sun on its path that is known as the orbit. Therefore, the orbit is a path that is followed by a heavenly body or by a body. Just it can be a heavenly body, that can be a moon, can also be planet, to go around another planet or around the sun. Therefore, it is simply a path that is followed by a heavenly body to go around another object such as the sun. It can be the earth going around the sun, or it can be moon going around the earth. It follows a special path that is called orbit. Let's look at the types of tides. As we have been able to look at the various movements that the earth makes, just to remind us, we have revolution, and then we also have rotation. These are the 2 movements that are caused by the earth. As the earth revolves around the sun, revolution is about the sun. It goes around the sun. Just to remind us, it's around the sun. And then rotation is around on axis. Therefore, those are the 2 movements that are caused that the earth makes. And then lastly, as the earth makes a rotation, it causes the tides. And we have been able to see the rising and the falling of the tides have been caused by the rotation of the earth. As the earth rotates, it moves, it creates what we call types of tides. And that tide, we have been able to identify them. We will explore various of them in details as we'll be looking at the global system of the ocean currents. One of the tide we've been able to identify is the Perigean Tide. Perigean Tide. And then the second tide we have been able to look is the Perigean Tide. And then we also have the Neap Tide. These are the various types of tides we have been able to look at throughout, and that becomes the end of our lesson today. We will continue in the next part. Thank you.